Hello and welcome tech enthusiasts to ANARC's Introduction to Robotics series. Imagine a world where machines assist us in every task. A world where science fiction becomes a reality. That world isn't just on the horizon, it's already here. This video series is designed to guide you step by step into this fascinating realm of robotics, and what better place to start than the PTC Gymkhana, the heart of innovation at NIT Agartala. As part of the Winter School of Technical Skills, you're in the perfect environment to explore, learn, and grow. In this very first episode, Robotics Unplugged 101, hosted by me, Vidhi Mittal, a second year student from the Computer Science and Engineering department, and my co host, Nancy Raja Parmar, a second year student from the Electrical Engineering department, we will cover the fundamentals of what robotics is. This isn't just an introduction, it's a beginning of a journey into the extraordinary. Given in our social media handles, follow us for further updates. So, without further ado, let's dive in and unlock the mystery of robotics. Today, we will be covering how to define robotics, what robotics essentially is, the laws that govern it, the key components behind the robots, the types of robots we interact in our day to day life, the myths and the facts that have been said about robotics from generations, the kinematics behind robotics, and finally, a conclusion giving you a full idea of the potential of robots. Now, robotics isn't just an engineering discipline, it's a field that merges creativity, intelligence, and a technology to solve real world problems. From ancient automata to modern day humanoids, robots have come a long way. Today, robots are everywhere, every scenario, cleaning homes, assisting surgeons, and even exploring the depths of space. But how do they do it? Their secret lies in their design and functionality. Intersection of intelligence and engineering is what makes robots unique. It's not just about building machines. It's about creating solutions that actually enhance our lives and expand our horizons. We have proved time and again that robotics aren't just machines. They are technological marvels combining sensors, processors, and actuators to perform we once thought were impossible. Hence, we need to establish a solid definition to address such diverse fields. To understand robotics, let's start with its definition. Robotics isn't just one thing, it's a multidisciplinary field. For some, it's a hobby. For others, it's an industrial necessity. And for dreamers, it's the cornerstone of a futuristic vision where machines coexist with humans. At its core, robotics is the science of designing, building, and programming machines to perform tasks. But these aren't just any machines, they are capable of learning, adapting, and even interacting with their surroundings. Let's break it down into the four defining characteristics. Automation. Robots operate independently, handling tasks without constant human oversight. Think of a robotic vacuum cleaner, mopping your home or cleaning it effortlessly. Precision. Assembling microchips to performing complex surgeries. Robots execute tasks with unparalleled accuracy and reliability. Adaptability. Robots aren't static. They adapt to dynamic environments, whether it's navigating uneven terrain or responding to unexpected obstacles. Interaction. Robots can interact with their humans and the surroundings around them, creating synergy in tasks ranging from customer service to disaster response. Imagine this, a robotic arm on a factory assembling a product with zero errors, zero. A drone delivering medicines to remote areas. These are not dreams, they are applications of robotics showcasing its incredible potential. Now, let's address a very critical aspect of robotics, the ethics behind it. Picture a world filled with machines, smarter than humans, capable of learning and evolving. Without rules, it would be a chaos, a scenario ripe for dystopian nightmares. Recognizing this, Sir Isaac Asimov proposed the laws of robotics, a set of principles designed to ensure harmony between humans and machines. These laws weren't bound out of thin air. They arose from a pressing need to guide the behavior of intelligent robots. Let's explore them in detail. A robot might not harm or injure a human being or through inaction allowing a human being to come to harm. This law ensures that robots prioritize human safety above all. A robot must obey the orders given it to it by human beings, except where such orders will conflict with the first law. This ensures that robots remain subservient but within the ethical boundaries. A robot must protect its own existence as long as such protection does not conflict with the first or the second law. This enables self preservation while ensuring it doesn't come at the cost of human safety or obedience. These laws from the moral backbone of robotics, ensuring machines remain tools for progress rather than instruments of chaos. Imagine a robot nurse in a hospital prioritizing patient safety while following the doctor's orders. These scenarios highlight how Asimov's laws are not just theoretical, they are a practical necessity for guiding robotics behavior. Finally, let's unravel the secret behind a robot's abilities. Every robot operates through a combination of five essential components, or collectively known as the automation pentagon. These five pillars form the foundation of every robotic system. Sensing. Robots perceive their environment using advanced sensors like cameras, lidar, and infrared detectors. For example, self driving cars use sensors to detect lanes, obstacles, and pedestrians, enabling them to navigate such obstacles safely. Processing. After gathering data, robots process it using powerful algorithms and AI. This is where decisions are made, like a surgical robot calculating the optimal incision point. Actuation. It's the muscle of a robot, motors, gears, and hydraulics that converts decision into actions. Robotics arm assembling cars or robotic legs navigating through terrain rely on precise actuation. Connectivity. Robots aren't lone warriors. Using IoT or the Internet of Things, they communicate with each other and external systems, ensuring seamless collaboration. Picture a factory where robots coordinate tasks in real time to maximize efficiency. Software. At the heart of every robot is its brain, the software that integrates all these components. Frameworks like ROS, Robot Operating System, enables robots to function smoothly, adapting to challenges in real time. Together, these components transform robots from simple machines into intelligent systems capable of tackling complex tasks. Now, I will pass on the mic to my co host to dive into the further topics of this video. Thank you.
We have come to the second part of the video. In this part I am going to cover the type of robots, myths and facts related to robot kinematic of robotics and the conclusion. From the ancient time when we have designed a mechanical robot to the current time when we have humanoid robots, we have evolved a lot. Now robots are working as a waiter in some restaurant. They are painting the walls. They can do all the small things uh, earlier which only a human can. In almost every field, we have robots. Now, today I'm going to tell you about some main type of robots. First one is pre-programmed robots. Pre-programmed robots are programmed to perform a specific task. They can't perform all tasks, but they are expert in performing a single task repetitively. For example, assembly line robots. They are designed to do a task repetitively. For example, in a factory, there are some machines to pick something from a place and to keep it on the other place. For example, like this, this can pick a thing from here and place somewhere here or there. Some machines are to pack a packet. Some machines are used for manufacturing. Those are known as pre-programmed robots. Second one is humanoid robots. Humanoid robots, as the name suggests, they have human-like appearance and interaction. For example, we all might have watched the movie Robot, in that Chitti is a humanoid robot. Humanoid robot can perform every task we can, like we actual human can. In real life, we have example of Sophia. Sophia is the first humanoid robot. She have a human-like appearance and she can perform all human tasks. Third one is autonomous robots. Autonomous robots are something which work independently without the interruption of a human. We just need to give them command and they can perform the whole task without any help from us. For example, a self-driving car or Alexa. We just need to give them command. They will do the whole work. Fourth one is teleoperated robots. As the name suggests, we have to operate them. For example, a remote control car or a drone. For a drone, we have to use a remote to move the drone up, down, or to stop it, to start it. Right? So it is the example of teleoperated robot. Fifth one is augmenting robots. Augmenting robots are something which have ability to perform a task like a human. For example, a ecoskeleton. Ecoskeleton is something which have a human-like functionality. For example, a artificial hand or a artificial leg. Here you can see this hand can work like a human hand, but like human hand if someone lost his or her hand or in any case of incident. So these robots are very helpful for us in performing some tough tasks. and to enhance, to increase our productivity. So now let's move to the next part. In this part, I'm going to address some common misconception about robotics and providing factual insights to reshape our understanding. Let's break it down. First myth is robots are here to eliminate job. It is a very common myth nowadays, that robots are here to replace human in almost every field. They are replacing human. They are eating the jobs. The actual fact is robots are here to help us. They are here to create new opportunities by automating repetitive tasks. They can work as a helping hand for a human. Nowadays, robots are getting replaced by cobots. Cobots are something like collaborative robots. Collaborative robots are designed to perform tasks for humans without hurting or harming them. So, nowadays, robots are created to help instead of harming. To support what I'm saying, I have some facts. For example, autonomous robots or autonomous cars, they still need a lot of improvement. They are far away to replace a human being. We need robots in almost every field to make our work easy and efficient. For example, in manufacturing or logistics, they rely on robotic robots to survive. In a big factory or somewhere when we have to create a lot of things, a lot of production, we need robot to work instead of human being. Why? Because robot can perform a work faster. They don't make mistake more frequently, and they don't need break like a human being. For example, if we are setting a factory, we have some work which a robot can do, and our labor also can do the same work. But in comparison of a labor, robot can do the work more efficiently. Like they need very less time to do the work, and they don't need breaks. So it is like very important to incorporate robots in our work to make our work easy and efficient. Next myth is robots are too expensive. I do agree with this, that robots are expensive, but for short term. They are cost saving for long term. Again, take the example. Let's just take the example of a factory. For like in a factory, if I am setting a robot to perform a particular task, for the time being, when I'm buying the robot and setting it in the factory, it may cost a lot for me, but over the time, it is going to save my money only. So what we have understood is robots are not our enemies. They are not even enemies of progress. They are the engines driving it. Robots are here to work as a helping hand for human beings, not to harm them. Now let's move to the next part. Now we will study the kinematics of robotics. What is kinematics? Basically, kinematics is like giving direction to robot's body. Where does its hands or arm need to go? How fast should it move? What angle should its joint bend to reach the target? Without studying the kinematics of a robot, it is not possible to create a robot. So, in order to create a robot, we should know all the kinematics, like the locations of hand and joints, the velocity of and effectors, internal joints. If we know all those things, we can easily calculate the other thing. For example, forward and reverse arm kinematics. In forward arm kinematics, if we know where the joint is, for example, let us take a hand. For example, like let's consider this is a hand of a robot and this is a joint. Okay, so if we know there is a joint, then this we can easily calculate that this hand can move here or here, right? So this is forward arm kinematics. In reverse arm kinematics, it's just opposite. If we know the place where we want to reach, for example, here is a glass. Okay, we want to pick this glass. So on the basis of the place we want to reach, we can calculate where the joint should be. Mm, okay. Mm, Earlier we know that glass is there and we have to pick this glass. So we can make a joint here by calculation and we'll pick this glass. So this one is a part of inverse arm kinematics. These kinematics are very, very useful while designing the hands and legs of a robot to ensure proper working. Next one is statics kinematics. Statics kinematics is basically the studying of force acting on a robot when it is at rest. For example, let us consider a robot is like there is a box, robot is keeping a box. Okay, so um, to ensure that the robot do not drop this box or it do not tip over the box, we should ensure that force acting on a box from the side of a robot and force acting due to the weight of a box on robo should be balanced. If all the forces acting on this box and robot is balanced, then a robo can easily keep this box at rest. This is what study of statics is, statics kinematics. Now next one is dynamics. Um, In dynamics part, we will study about the driving force, motion, speed, energy of a robot while moving. This ensures proper working of robot in the motion. Next one is trajectory control. Trajectory control ensures that robot moves smoothly along a planned path. Like by trajectory planning, we earlier plan the path in which robot should move, and trajectory control will ensure this movement by using some actuators or motors. For example, if we want a robot to draw a straight line, then it should not bobble like this or this. To ensure these all things, we have to consider the trajectory control and trajectory planning beforehand. Next one is path planning. Path planning is basically determining a collision-free and effective path to accomplish a task. Uh, Robots avoid obstacle while moving, but how a robot can sense like where is something, where is a hurdle in the path, how we can ensure a collision-free and effective path for a robot. Here we will use some sensors. Okay, sensing and perception is the process by which a robot can ensure a collision free and effective path. Earlier we are in the components of robotics, we have studied about the sensors. These sensors will sense about the external environment. If there is something, for example, in a self-driving car, if there is a dog in front of a car, then these sensors can sense the presence of that dog, and perception, like there is some devices to percept and take actions accordingly. This will ensure a proper path to um, car to move and reach the um, required location. Then next one is task planning. Task planning is basically to determine the actions to accomplish a higher command. Okay, task planning is like creating a to-do list for the robots. It figure out the steps needed to complete a bigger task. For example, if a robot is need to assemble a furniture, then it should decide the steps like first it will attach the legs, then seats, then cover, and so on. So this all comes under the task planning. Kinematics of robotics is very necessary to know before designing a robot. It will be the basics to design a robot. Now the conclusion is, where are we headed with robots? Robots have come a long way from simple machine to super smart tools that can help in almost every areas of life. They have moved beyond just being industrial tools and are now helping doctors, like in Big Hero 6. They are helping to perform surgeries with amazing precision, cleaning our rooms, cleaning our walls like uh, some robot vacuums, Wally, exploring spaces with machines like NASA's Mars rover. We can't go to Mars, but a robot are there. They can survive there and give us information about them. It is all just possible because of the curiosity of a human mind. So it's not about whether robots will be part of the future. They already are. The question is, are you ready to build your own bot? Are you curious to be the part of this exciting journey? The future of robotics isn't just in hands of engineers, it's in the hand of everyone with a vision. Let's collaborate, innovate, and build something extraordinary together. With these final thoughts, I want to end the video here. I hope you have learned a lot from this video and you are curious to dive deeper um, in the concepts of robotics.